Hello everyone. Let us discuss stepwise approach for titration. So let's start. Aim to prepare M by 20 solution of ferrous ammonium sulfate, which is a Mohr salt. Using this solution, find the molarity and strength of the given KMnO4 solution. Second step, we have to write material required. So here chemical required are potassium permanganate, Mohr salt, sulfuric acid, and apparatus we require for the titration: burette, pipette, test tube, beaker. Third step, we write ionic equation. Always preferably write ionic equation in place of molecular one. So here ionic equation, we have an oxidizing agent permanganate, reducing agent ferrous, which comes from Mohr salt, and medium is acidic medium. Potassium permanganate is a powerful oxidizing agent in acidic medium. So in acidic medium, permanganate ion, which is purple in color, changes to divalent Mn2 plus, divalent manganese ion, which is colorless, and ferrous, which is a reducing agent here, changes to ferric part. Indicator, KMnO4 is a self-indicator. Next step, we write endpoint. Endpoint for this titration is colorless to permanent pink color. And we take oxidant in a burette, KMnO4, in a burette we take, and Mohr salt in a flask. Then the next step is observation. First step of observation is to prepare 250 ml of M by 20 Mohr salt solution. For this, what we do, we write a molarity formula. Molarity is number of moles upon volume into 1000. If volume is given in ml, then in order to convert it into the liter, we use a conversion factor of 1 liter equal to 1000 ml. Number of mole, and that one is equal to given mass upon molecular mass. So net formula for molarity, that becomes M equal to W upon molar mass into 1000 upon V. Molarity is 1 upon 20. W we have to calculate. Molar mass of Mohr salt is 392, and volume we have to prepare, we are preparing here is a 250 ml. And on simplifying this, we get 4.9 gram. It means if you dissolve this 4.9 gram of Mohr salt in 250 ml of water, distilled water, then the molarity of the resulting solution will be M by 20. So by this way, you can easily prepare M by 20 solution of Mohr salt. Now after preparing the solution, next step is a observation table. So volume of the Mohr salt prepared, that one is 250 ml. Molarity of the Mohr salt is M by 20. Volume of Mohr salt taken out for each titration is 20 ml. That is the pipette out volume is the 20 ml I have taken here. In place of 20 ml, you can also pipette out 10 ml. Now observation table. So for observation table, we make 4 columns: serial number, initial reading, final reading, and the volume of KMnO4 used. We take 3 readings. Initial reading, we usually take 0. Start from 0. Final reading, in the case of M by 20 Mohr salt solution, you can take your final reading comes in a range of 13 to 20. You can write any numeric value in between the range of 13 to 20. In each and every case, your answer that comes out is 0.01 mole per liter KMnO4 solution. So suppose here I am taking 15 ml. Okay, so the volume of KMnO4 used here is 15 ml. Now the concordant volume, it doesn't mean that you have to take a mean value here. It means all the 3 readings must be same. It's not like, okay, first reading you are taking 15, next one is 17, and the third one we are having 14, and finally for concordant you are writing like 14 plus 17 plus 15 upon 3. This is the wrong way. Concordant means all the 3 values must be same. So here our concordant volume is 15 ml. Now next step, calculation. What we have to calculate, what is given in a question, we have to calculate molarity and strength. of a KMnO4 solution. Yes, if you cross-check your ionic equation, then in your ionic equation we found that 2 moles of potassium permanganate are required against 10 moles of Mohr salt. So for this purpose, we use a molarity equation for potassium permanganate and Mohr salt. M1V1 upon N1 equal to M2V2 upon N2. Molarity we have to calculate. Volume 15 I have taken. How many moles? 2 moles. Molarity of Mohr salt 1 by 20. Volume of Mohr salt 1 by 20 and the number of moles 10 moles. And after calculation we get 0.01 mole per liter. Okay, so the molarity of potassium permanganate comes out 0.01. Then the next step is the strength. Strength is molarity into molar mass. Molarity of potassium permanganate is 0.01 and molar mass of potassium permanganate is 158. So strength comes out 1.58 gram per liter. This is what I am saying. Okay, you can take any value in the range of 13 to 20. Then your answer that will always be molarity comes out 0.01 and strength 1.58. Because we usually prepare m by 100 solution of potassium permanganate. Okay. Now after the calculation, next step is to write the result. Molarity of potassium permanganate is 0.01 mole per liter and the strength is 1.58 gram per liter. Then the last step is to write the precaution. Handle the chemical carefully. Do not taste the chemical. So this is all about how you have to write in your board exam for the titration of Mohr salt with potassium permanganate. Now the next titration is of potassium permanganate with oxalic acid. Aim here is to prepare m by 50 solution of oxalic acid. Using this solution, find the molarity and strength of given potassium permanganate solution. Second step, we write material required. Chemical required here are potassium permanganate, oxalic acid, sulfuric acid. Sulfuric acid we require 4N of sulfuric acid. And the apparatus we require here, burette, pipette, test tube and beaker. Third step, we write ionic equation. MnO4 minus 2 moles react with 5 moles of oxalate C2O4 2 minus. MnO4 minus changes to Mn2 plus in acidic medium and oxalate ion changes to CO2. Here permanganate act as an oxidizing agent and oxalate ion, that one act as a reducing agent. Next step, indicator we write. KMnO4 is a self-indicator. Endpoint colorless to permanent pink. KMnO4 we fill it in a burette and oxalic acid we take it in a flask. Now next step is the observation. Again the first step is to prepare 250 ml of m by 50 oxalic acid solution. So we use a molarity formula here, m equal to n upon v and the number of moles, and that one is equal to the given mass upon molar mass. And if volume is given in ml, then we use a conversion factor 1 liter equal to 1000 ml. So m here is molarity, here is 1 upon 50. W we have to calculate and molar mass of oxalic acid is 126. We are having a hydrated oxalic acid. We are using hydrated oxalic acid here. And the volume we are preparing is 250 ml. And after solving this, we get 0.63 gram. So if you dissolve 0.63 gram of oxalic acid in a 250 ml of water, then the molarity of the resulting solution will be m by 50. So by this way, you prepare m by 50 oxalic acid solution. Volume of oxalic acid solution prepared 250 ml. Molarity of oxalic acid, that one is m upon 50. Volume of oxalic acid, that one is taken for each titration, is 20 ml. In place of 20 ml, you can also pip it out 10 ml here. Now the next step is a observation table. Again 4 columns. First for the serial number, Next one is the initial reading, then final, and then the volume of KMnO4 used in ml. Initial reading, we always take 0 ml. Final reading, as I earlier tell you about told you, okay, volume of KMnO4 used, here it comes in the range of 11 to 16 ml. You can take any value in this range, then your final answer will always be 0.01 m KMnO4 solution, and the strength comes out 1.58 gram per liter. Suppose like here I just take 13 or 14 ml. So 13 ml, and it concordant volumes comes out 13 ml here. Now the next step, calculation. To calculate molarity of KMnO4, you just check the ionic equation. 2 moles of potassium permanganate react with 10 moles of oxalic acid. We use a molarity equation, M1 V1 upon N1, which is we use for KMnO4, equal to M2 V2 upon N2 for oxalic acid. M1 we have to calculate. V1 I have taken 15 ml. N1 V1 I have taken, sorry, not a 15 ml, I have taken 13 ml. N1, that one is 2, M2 is 1 upon 50, V2 is 20, and N2 is 5. So M1 here comes out after solving it 0.01 mole per liter molarity of potassium permanganate. 0.01. The next step is the strength of potassium permanganate. Strength, that one is equal to the molarity into the molar mass. So what we do, 0.01 molarity of potassium permanganate into molar mass of potassium permanganate, and it comes 1.58 gram per liter. Last step, sorry, second last step, we have to write result. So molarity of potassium permanganate is 0.01 mole per liter, and the strength comes out 1.58 gram per liter. And then finally result, handle the chemicals carefully, do not taste the chemical, do not overheat the chemical.